All right. So, what we need to do is to really lay strong foundations for success in this class. And I'm going to lay that foundation today so that future problems will not be difficult. Now, what we're going to talk about is the foundation of inferential statistics, okay? So the foundation of inferential statistics is to understand what is inferential statistics. Inferential statistics is where we use the sample from a population to make judgments or to make inferences about the characteristic of the population. And what characteristic are we going to talk about for this class is the mean, the average. For example, what is the average travel time for students to come to school? What is the average price of houses in a neighborhood? What is the average mileage that a car travels in 1 hour? What is, say, a rental customer comes to rent a car? What is the average mileage of the cars that they rent? So these are examples. What is the average income of people in a neighborhood? What is the average age of kids in a class, and so forth and so on? So these are the kinds of characteristics we are talking about. So we're going to do an example today to illustrate that, because it's a foundation of what we are doing. Okay, so I'm going to share screen and provide you an example. Okay. Okay, there is an example up here. It says, download the MS Word and MS Excel files to complete an assignment. Okay. Using the MS Excel processor, calculate the average price per square foot for houses in 2 neighborhoods. Okay, there are 2 neighborhoods. You calculate the average price per square foot for houses in the 2 neighborhoods. And then you calculate the standard deviation of the average price per square foot. So these are, the bits of information that you need in order to do inferential statistics. Now, where are we going to begin? We're going to begin with confidence intervals. And what is the problem that we want to define in a confidence interval? What is the problem that we have? The problem that we have when we are talking about a confidence interval is that we take a population, for example, the population of students that came to school today, okay? All the students that came to school today will be the population, not the population of registered students at Medgar Evers College, but only the ones that came to school on a particular day, okay? And we say, what was the average travel time from their homes to the school? Okay, so that's a bit of information. And we want to get that information, okay? What is the average GPA of students that transferred into Medgar Evers College? Not all students, but those that came in by transfer. What is their average GPA, okay? And so now we don't know what that average is. We don't know what the true average is, but we're going to make an inference about it using the population. And how do we make that inference? What tools do we have that enable us to estimate? Because all we're going to get is an estimate. And when we get that estimate, then we use it to make a judgment about what the true average is. All right? So this problem then continues. Says, for each neighborhood, establish a 98% confidence interval for the average price per square foot of houses, okay? And then based on your results, not what you think, okay? Based on the calculation that you are going to make, do you have any reason to believe that average price per square foot is significantly higher than the average price per square foot in the other neighborhood, okay? So in statistical analysis, you don't just say, I think. No, you do a calculation and then you use that calculation to really make a statement and say, but look at the numbers, okay? Look at the numbers. So the analysis is based on numbers, not what you think. So now I'm going to stop share this and share the Excel file on which it is based. Okay, so here is the Excel file. And so this is the original data. So you use this original data and calculate the average price per square foot for this neighborhood. You can see there are two neighborhoods here, Aroche and Borough Park. Okay, there are two neighborhoods. So you calculate the averages, and the averages are calculated here. I'm going to make that big. Okay, the averages are calculated there. And so you use these averages to establish what is called a confidence interval. What is a confidence interval? And I'm going to stop share this. We have calculated the averages. And so I will now share again. Okay, so we have the average that we calculated. We have a standard deviation. We have the names of the neighborhoods. And so we do what is called a confidence interval. Now, the confidence interval, remember, we have to set a percentage level of confidence. Now, a confidence interval simply says, I don't know what the true average is. The true average, as you can see here, is in the middle, okay? The true average is right there in the middle, okay? And so we don't know what the true average is, but the true average will be between a lower value and an upper value. The values that you calculate are based on the normal distribution, okay? Normal distribution. So I'm going to write that down. And I'm going to show you what the normal distribution looks like. We're going to use the normal distribution. Okay. I think I'm going to. All right, so our calculations are going to be based on the normal distribution. And so, and there's a formula here, okay? And this Z value is based on a hypothetical distribution with a mean value of 0 and a standard deviation of 1. So again, I'm going to pull up that normal distribution so that you can see what we're talking about. Now, in order to do a confidence interval, you must select a level of confidence, a 99% confidence, a 98% confidence, a 90% confidence. If you choose a 90% confidence, you are saying that you are taking into consideration that you're going to be 10%. There's a possibility that you're going to be, there's a 10% possibility that you're going to be wrong, okay? If you choose 99% confidence interval, you are taking the risk that you are saying that there's a 1% probability that you are going to be wrong, okay? So you choose your own level of confidence. That's up to you as a statistician. You choose 95%, you choose 99%, 97%, 98%. And so you do your calculation, and there's a Z value that corresponds to a 99% confidence interval. That's a Z value that corresponds to a 98% confidence interval. So Once you choose that, you have your information. The standard deviation, you have calculated it. You can use S here. You can use S there if you want. That is the sample standard deviation. Okay. And so let me pull up the standard number distribution so that we see how we select a Z. Okay, so I'm going to stop this share for a moment. And so give me a minute so I can get. All right, so you see the standard number distribution on the screen. Are you able to see it?
Yes, I see.
Okay. Now, the standard number distribution, as you can see, it's a symmetrical distribution. It has a symmetrical curve, okay? The mean value is 0 and the standard deviation is 1. So if you go to the right, you can see the number distribution has an area here, okay? The area of one side of the number distribution is 0.50, that is a half, okay? The area on the left side is 0.50. So 0.50 plus 0.50 is 1. 1.00, or the 100% of the entire distribution. So now that you see the standard number distribution, then how do you use it to do a confidence interval? All right. Can you see it clearly?
Yes.
Okay. You can see it clearly, then it's fine with me. Okay. Now, when it you can see that the table shows only one side of the distribution. But if you go from one side of the distribution to the other side, you're dealing with the same area, okay? As long as you take the same steps. If you have one standard deviation or two standard deviations on one side and on the other side, if you add them together, you get the entire area of the distribution. So now if you think about a 99% confidence interval, what is half of 99%? Can you use your calculator to give me half of 99%? Hello?
Yes, it is 0.495.
0.495. Okay, so you go under the table here and look for 0.495, 0.4949, 4948, 4951, and 4949. So we can choose one of them, okay? So it is 2.5, the corresponding Z value is 2.5, and you go all the way to the right to 0.4949, and under 0.4949, you have 0.07. Is that correct?
Yes.
Okay.
Yeah.
So you take 2.5 and add 0.07 to it, which gives you 2.57. Okay. So the corresponding Z value for a 99% confidence interval will be 2.57. Is that clear?
Yes.
Okay. That is clear, fine with me. So we can now proceed. So when we do our calculation, we're going to stop share this and go back now to the calculation that we have here. So what we are going to do then is that so we're going to take X bar, which we have as 297.3. You can see it here, 297.93, which is the average, right? Which is your X bar, the sample mean. We're going to copy this to make it easy for everybody. So we'll now replace this X bar with 297, 297.93. minus, in the bracket here, 2.57. The standard deviation from the table up here, the sample standard deviation is 118.06. 118.06. And the sample size, as we know, is sample size n is equal to 40. Okay. And here we have Z, 2.57. The sample standard deviation is 118.06. And the sample size is 40. So that is the formula, okay? Once you do that, you ask yourself then, what is the confidence interval? Okay, what is the confidence interval? And so you do the calculation. Can somebody give me I'm going to copy this. We're going to have it there. Okay, so 297, what is what is the square root of 40?
Square root of 40 is
6 point.
Sorry, hold on. Wait.
Professor, are you sharing your screen? I can't see anything.
Oh, okay.
Okay, I'm sorry.
Thank you very much.
You're welcome.
All right, can you see my screen now?
Yes.
Yes, you can see.
Okay, so,
The square root of 40 is 6.324.
okay, 324. Let's take 324.
Yeah.
Okay, and here is 6.324. All right, so now you can see we reduce the formula and we can now take the same equation. All right, so 118 divided by the square root by 6.324. Okay, 118.06. So we have to take the square root out. We have to take the square root out. Okay, so we have 6.324. We have 6.324. Okay, so 118 divided by 6.324 is what?
18.668.
Okay, 18.668. And so we take that. I want to go through it systematically so that everybody sees what we're going through. And so this is times 18 point what?
668.
668, okay. 668 and times 18.668. All right. And so So now 2.57 times 18.668 is what?
It would be 47.978.
978. And put the same thing over here, 47.978. Okay. And so we take that, put it here. And what is 297 minus 47.978?
297 point minus 47. It is 249.
249.
0.952.
952. Okay. And what is 297? All right. And so all right. So what is 297 plus 47.978?
It's 345.908.
908. So now you can now say, now that you have this calculation, you can now say, I don't know what the true average price per square foot is, but I am 99% confident that it will be between 249.952 and 348.908. That's what you can say now, having done the statistical analysis, okay? So the question then becomes, how do you then use this information to say to yourself that the two neighborhoods are likely to have two different prices per square foot? How are you going to be able to do that? You go through exactly the same calculation using the other information. So we're going to do that, okay? We're going to do that. And we see that for the other neighborhood, the average sample, sample average price per square foot is 275.04. And the standard deviation is 66.36. And what is the sample size? Okay, I'm going to give you the sample size from the table here. The sample size is from 42 to 2. It's 49. The sample size is 49 for the other neighborhood, okay? So we don't have to go through a lot of writing down the formula once more. So let us use the old formula. We're doing exactly a 99% confidence interval, okay? So this is for neighborhood number 2, okay? Go through the same process, but instead of 297.93, we have 275.04. And here we have 275.04. This, we're using the same 99% confidence interval, so 2.57 will not change, but what we have here will change to 66.36, and the sample size is 49. And here we have the same 66.36, and the sample size is 49. All right, so we'll go through the same calculations, and we copy that. We know the square root of 49 is 7.
Mm-hmm.
Okay. So the square root of 49 is 7. The square root of 49 is 7. The same process. Okay. And so we take that. Okay. So what is 66.36 over 7?
It is 9.48.
Okay. Times, this is what, 9.48?
Yes.
Okay. And we'll take this. Times 9.48. All right. So usually mathematics. Take that down. What is 2.57 times 9.48?
It is 24.363.
24.363.
Yes.
363. And we'll go through the same thing here, 24 points. And we add 24.363. All right. And so copy that down. Okay, so what is 275.04 minus 24.363?
250.677.
0.677. And what is 275.04 plus 24.363?
It is 299.403.
Very good. So now we have the calculation for the other neighborhood, right?
Yes.
We have the calculation for the other neighborhood. And so now we say to ourselves, how can we use this to say that the average price per square foot in one neighborhood is different from the average price per square foot in the other neighborhood? That is the question. So let us copy the first one. So for neighborhood 1, we can say with 99% confidence that the average price per square foot is 249.95, is between 249.95 and 345.908. For the second neighborhood, we can say with 99% confidence that the average price per square foot is 249. Is 250.67, is between 250.677 and 299.403. So can we say with 99% confidence that the average price per square foot in the two neighborhoods is different? So now this is how you look at it. You can see that for neighborhood 1, the average price per square foot is between $249 and $345. Let us use that for sure, right?
Mm-hmm.
So that simply means that the average price per square foot is anywhere within that range. For neighborhood number 2, this is neighborhood number 1. Call it number 1. And this is number 2. Okay. And for neighborhood number 2 is between 249 and 345. Do you see an overlap?
Yes.
There is an overlap because the average price per square foot in one neighborhood, which is lower, if you shift this 249 a little bit lower, it's just a little bit lower than the lowest possible price for neighborhood number 1. Just
Mm-hmm.
a little bit below the lowest possible price. And so there is an overlap in the sense that the average price per square foot of neighborhood number 1 could as much be 290 as for neighborhood number 2. You get it?
Mm-hmm.
Okay.
Yeah.
Therefore, you cannot say with confidence that the average price per square foot in the two neighborhoods are definitely different. You cannot say that. Okay. Suppose that the average price per square foot for neighborhood number 2 is between 230 and 244. Then you can say that they are different because the highest possible average price for neighborhood number 2 is below the lowest possible average price for number 1. Then you can say they are different. All right?
Okay.
Okay. So now, having said that, we have an understanding of how to interpret and use statistical data. Next time when we come, we're going to extend this and use it for what is called hypothesis testing. All right? So does anybody have any other questions? Have any questions?
No question.
Okay, hearing none. Then it's nice having you all. I expect everybody to do their homework assignment. Please do your homework assignments so that you can pass the class. All right? Okay,
Thank you, Professor.
Okay, have a nice
Thank you,
evening.
Professor.
I'm going to pause this. All right, have a nice evening.